Coming up, guys.
Abyssal flames take up a large part of our oceans, and the Pacific is the largest of that. They're very flat, almost featureless environments. So people don't come here often, but they play an incredible part. There's still animals that live out there. Is it homogeneous across the whole thing? Probably not. How many organisms are actually there? That's what we're here for. My name is Todd Bond. I'm a research fellow at the University of Western Australia, and I'm chief scientist here on third leg of the TransPacific voyage with Inkfish. The second leg was from Honolulu to Papeete, and the leg that we're on right now, leg 3, will be going on the western side of that same transit back to Honolulu. This trip itself is specifically targeted to sample down from 4,500 to about 6,000 metres.
I've been so excited for this trip. Yeah, definitely a lot of anticipation leading up to it. I'm Meg. I'm working as a research officer for the Minderoo and University of Western Australia Deep Sea Research Centre. My role on this trip is to not only do the video analysis, but I also help out with the lander deployments.
Oh, did you get some in your base?
Trying to understand how organisms are distributed through an ocean this large is very difficult. The way that we are approaching that question is by pure number of samples. Between here and Hawaiian Islands, we'll be deploying 21 landers. Each of the landers has video and some small traps as well.
We just collected the first lander from this morning. We're just going to look at the Nalgene canisters to see if we have any little amphipods or anything in here.
Amphipods we've been collecting across all of the transits that we've been doing. Firstly, they're easy to catch compared to other things like fish. We can get them in high abundance. Get much?
There's a couple of things.
Chunks of bait.
Yeah, look at this one. Just a big boy.
As we get deeper and deeper, a lot of organisms can't deal with that high hydrostatic pressure, and so that's where they fit best. They're filling a functional role that other animals are not filling at that depth.
We'll take him for sampling.
The gene flow in those particularly deep areas is so low that over time we have new species. And that's the primary reason for collecting them on this voyage, the genetics. Are the organisms on the eastern side of the Pacific the same connected population to what we're seeing on the western side of the Pacific? And when we have lots of something, we can answer more well-tuned scientific questions.
The answer there's not much, but the fish have had a field day eating the bait, so that's good. We can look at the videos and see what's been chomping away at this. Nom nom.
Cool. This massive Basidius that's come in came straight in front of that little camera sticking at the end of the bait arm. Yeah, here it is. How cool is that? That's awesome. It is actually quite hard to collect fish at this depth. So we rely on really good imagery to give us the best information possible. Little amphipod going a million miles an hour, photobombed by a rat tail. Being able to get really close-up images of things like fins on fish or the scales on their face are really important characteristics to identify distinguished species. Those videos get disseminated across the scientists that go through and annotate the videos to get a really good understanding of the composition and abundance of the organisms that we're seeing.
The species is Ceratapsis monstrosus. So we attach to these points are lots of different information fields. It's got its family, its genus, and its species. We've seen quite a few cool critters from these deployments. It'll be interesting to see how the communities differ across depth ranges, latitudinally and longitudinally.
As we continue to head further north, depth extensions are important. So if we're getting animals finishing at 5,000 metres instead of 4,000 metres, that opens up a whole new part of the ocean that we didn't think that they existed in before. It actually has a lot of important meaning. First one up for the day. See what's in there, all right?
There's heaps in there. Oh my gosh, there's so many of this. On one of the last deployments that we did, it was a pretty shallow site. And yeah, we actually found approximately 200 amphipods, which was pretty crazy. Considering the depth, yeah, it's quite a lot. Really exciting.
The amphipods are really, really important. They're going to provide us a lot of sample and a lot of replication to run experiments on. One of the things the scientific community have done with a lot of amphipods is looked at contaminants that they have in their body.
Scientists have found a new species living nearly 7 kilometres below sea level.
Meet Eurythenes plasticus, named after one of its main characteristics, plastic. The new species already poisoned by humans above.
Even though we're in the deep sea, we may think that we're worlds away, but we do find a lot of these chemical contaminants. Visually seeing plastic bags is quite shocking, but seeing microplastics inside the gut of an amphipod is just as shocking. I think it's really important to explain that to the general public that nothing is really untouched anymore, which is pretty disturbing. Collecting data is one part. Now it's up to us to really kind of head down, bum up and start deciphering the things that we've collected and to sharing that with the world.
Oh, what is that? What is that?
But it's good to see a few really interesting little bits come out from a first pass analysis.
We've got lots of videos to analyse. Yeah, we should get a pretty interesting understanding of the Trans-Pacific region. Exciting stuff.
Yeah, for sure.
In terms of the story of the animals, I'll leave you guys hanging on. We'll just say watch this space on some interesting things that might be coming.